Hi everyone, I'm Serena Fu, a second-year PhD in the Fearon Group Molecular Rheumatology Lab. My project examines the underlying mechanisms involved in driving synovial invasiveness and joint damage in children with Down syndrome-associated arthritis. Down syndrome is caused by the triplication of chromosome 21, and with it comes a lot of autoimmune disorders such as Down syndrome-associated arthritis, or DA for short. In 1990, the world's largest case series of children with DA was reported with a total patient number of 9. However, this photograph was taken in 1884, and it's clear that this little girl who has Down syndrome also has inflammatory arthritis in her hands. Over the last 5 years, Children's Health Ireland in Crumlin, led by Dr. Orla Killeen, ran a nationwide screening clinic for children with Down syndrome. They demonstrated that it was hard to diagnose the disease because only a small percentage of them show an increase in the inflammatory markers ESR and CRP in comparison to juvenile idiopathic arthritis. This is in stark contrast to the site of inflammation because DA actually scores higher in terms of erosive disease and soft tissue swelling in comparison to JIA. While JIA has 7 different subtypes, DA only has 1 main subtype. And finally, from a clinical point of view, the prevalence of DA is 20 times higher than JIA. Firstly, these representative images show the synovial lining layer as indicated by the black lines from both groups. It's clear that the DA group actually has a higher synovial lining layer compared to JIA. This correlates with the increase in erosive disease seen clinically. From these synovial biopsies, we're able to isolate and culture primary synovial fibroblasts, which are the main invasive cell type in the joint. On the top left are representative images of invasion assays, and we can see that there are more DA fibroblasts that invade through the matrigel compared to JIA. In parallel, we use wound repair scratch assays, and we demonstrate here that there are more DA fibroblasts that repopulate the wound compared to JIA. Next, we wanted to look at the metabolic activity of these cells to see if they were linked with the higher invasive and migratory capacity. The representative metabolic profiles here show that DA fibroblasts have a higher glycolytic activity and oxygen consumption rate compared to JIA. We also looked at the expression levels of 3 metabolic markers, PFKFB3, GLUT1, and HK2, and we can see that the lining layer in DA scored higher for PFKFB3 and HK2 in comparison to JIA, while GLUT1, the glucose transporter, scored similar across the 2 groups. Together, this data shows that DA fibroblasts are more invasive and metabolically active compared to JIA. We next examined if metabolic reprogramming alters the inflammatory profile of DA fibroblasts using the glycolytic inhibitor 2DG. 2DG drastically reduced ECAR levels in the presence of TNF-alpha, resulting in the reduction of the ECAR-OCAR ratio. This led to a shift in the metabolic phenotype, transforming the DA fibroblasts from being highly energetic to a more quiescent state. Additionally, this metabolic shift in response to 2DG was paralleled by a reduction in the pro-inflammatory mediators IL-6, RANTase, and MCP1. These results show that DA is a more aggressive form of arthritis compared to JIA. DA fibroblasts have a higher migratory and invasive capacity that relies on an increase in the metabolic profile of these cells. Furthermore, glycolytic blockade of these cells results in an inactive phenotype and partially resolves inflammation. In summary, better treatment strategies and better understanding of the pathological mechanisms of DA are much needed. Finally, I'd like to thank Professor Ursula Fearon, the Molecular Rheumatology Group, as well as the patients without whom this would have been virtually impossible. And thank you for watching.